Okay. Um, so our lesson for today, as I said, is going to be series and parallel circuits. Okay, so let's go to the business of the day. So our topic is energy transfers as the main in electrical system, and the subtopic is just series and parallel circuits. So we're going to look at them one after the other. It is anticipated that by the end of this lesson, you should be able to explain what is a circuit, what is a parallel circuit, what happens when you connect more components in a series or in parallel, the different types of electric circuits, if all light bulbs in a house are part of the same circuit, how can you switch one light off without the rest also turning off? Okay, so, and then we should also be able to remember the components of a circuit as well. All right. Now, in the last chapter, we looked at what static electricity. So we are now going to focus on what current electricity. Uh, you are already familiar with some of the concepts about what uh, electricity from the previous grade. Okay, so we are just going to revise and extend our knowledge on this one. Okay, now let's look at what series circuit. So what is a series circuit? A series circuit is one in which there is only one pathway or pathway for the electric current to flow. So a series circuit is a circuit in which there is only one pathway for the electric current to flow. All right. The components are arranged one after another in a single pathway. When we connect the components in that gives us the same single pathway, they are said to be what? Connected in series. Now, so this is an example here, examples of two diagrams. So we have a series connection with one pathway for the current from the negative terminal to the positive terminal of the cell. So you can see that we have got, so the components of this circuit are, we have got a bulb, we have got a battery, we have got a switchboard, we have got a key, and then we have got a conductor. All right, so you can see that the bulbs, the terminals of the bulbs are connected to the negative terminal, and and one is also connected, and the other side is connected to the key or the switch, and then we have another conducting wire that is connected to the positive terminal to make a complete circuit. Now it will only be complete if the lights are on. If the lights are on, then it means current will flow. Okay, so this is a diagram. This is a diagram illustrating a series connection for two bulbs, and then you have A1 and A3, A1, A2, A3. I hope you have heard something called ammeter. All right, the ammeter is connected to do something to the to do something or take a measurement of something. What can somebody remember what the ammeter is doing here? Guys, if you are following, can you send in your answer so that I know that you are following? I've just mentioned that the diagram on my right hand side of my screen, I have got A1, A2, and A3. So I just wanted to know if you are following. And that A1, A2 is for the ammeter. And I'm asking you, what does it use for? What is the use for? Okay. Can you guys hear me? Can you hear me? All right. Okay, thanks very much. All right, so let's proceed. Okay, so we have defined series circuit, how the nature of the passage of the current. We have seen how uh, to use components to connect a series circuit, and we have seen also a diagram that is what that is representing a series circuit. Okay, now let's move on to the next slide. Now, and let's look at the characteristics of a series circuit. A series circuit is only provides one pathway for the electrons to flow. In a series circuit, there is only one pathway for the electrons to move through. The current strength is the same everywhere in that pathway. There is only one pathway for the electrons to flow. The current flows at the same strength everywhere in a series circuit because there is only one pathway. We say that the current is the same at all points in the circuit. Okay. Now, if you add more resistors in a series circuit, then if you add more resistance to the circuit, what is going to happen is that the current for the whole circuit is going to decrease. Now, in a series circuit, all electrons travel through every component, and the wire, as they travel through the circuit, all the electrons experience the same resistance, so they all move at the same rate. This means that in the diagram below, the readings on all three ammeters will be the same. So what it means is that A1 is going to be the same thing as A2, which is also going to be the same thing as A3. Why? Because we say the current is traveling or is passing through in only one way. So if it is passing only one way, at any point, if you measure the current at any point in time is gonna be the same thing. Okay, all right. I hope you get that. Let's go to the next. Why does current stay the same at all points? Let's go on. Why does current stay at at all points? Why does the current stay the same at all points? Now, do you remember that we spoke about the localized electrons in metals in the last chapter? Okay. The electrons in a conductor normally drift in various directions within a metal as shown in the diagram. Okay. Now let's look at the explanation. So what happens when we build a closed circuit with a cell as an energy source? The electrons will begin to move towards the positive terminal of the cell. The rate at which the electrons move is determined by the resistance of the conductor. So what it means is that there are some conductors that resist much, others do not resist much. Okay, there are electrons everywhere in the conducting wires and the electrical component. When the circuit is closed, all the electrons start moving in the same general direction at the same time. This is why a light bulb turns on immediately when you close the switch. So take note. Now, so what we are doing, we are simply using the property of the metal to explain this one here. You remember we said metals have got delocalized electrons. So that's why they are able to move from one place to another. So you can see that in this metal, in this diagram that we are talking about, A3, A2, A1 are connected to a metal conductor. And then this is the nature. That is a magnified version of what is happening in the conductor. So the localized electrons move freely in a conducting wire. Then the other one, when the wire is connected in a closed circuit, the electrons move towards the positive terminals, and then the current will start flowing. Okay, all right, now let's move to the next. Okay, so I asked a question, I don't know whether you followed me. The ammeter. Let me go back and you see something here. You see A1, A2, A3. They are connected to what? The terminal. So if I connect my terminal here, my ammeter here, the A1 side, I'm going to measure, supposing I measure 0.1 ampere or A, then I take it again, connect to A2 that side. I'm going to measure 0.1 ampere. I go to the same, to A3, do the same thing. Now it's just to prove that the current is what? Flowing in the same direction and in one passage. That's why I'm going to measure the same number or amount of current. Now let's look at the A. What is the A? The A is the ammeter. We have got the picture, the diagram there and the symbol. Okay. Now, an ammeter is a measuring device used to measure what? The electric current in the circuit. It is connected into the circuit in series. Ammeters have extremely low resistance because they must not alter the current they are measuring in any way. The current is measured in amperes, and the symbol for measuring an ampere is down there. Okay, the symbol for an ammeter is down there, and the unit for measuring amperes is for measuring current is the ampere. Amperes. Okay, so on my right hand side, you have a very nice diagram there showing you the what, the ammeter. And then in the second diagram, sometimes they use this symbol A. They use they write a cycle with an A in between. Okay. Google it, you can understand. What can't you understand? May you ask a question so that I will try to explain? Is it on the series circuit or the parallel circuit? Or currently what I'm talking about? Google it. May you, is your question for me? You said you can understand. All right, if you are hearing me and your question is for me, just post a question or just tell me which slide that I need to explain again. All right, otherwise I'm moving ahead. Okay. All right, now let's look at the way I'm just going to move back, and then you watch how the series connection was done. Yeah, look at it very well. Just look at how it is. Now I'm going back to the parallel circuit, and then you see whether they are the same. Are the connections the same? I don't think so. All right. So the way they are connected provides a certain advantage and a certain disadvantage. So series connection, the bulbs are connected in a different way. In a parallel connection, the bulbs are also connected in what? In a different way also. All right. Now let's go on. What is a parallel circuit? Parallel circuit are circuits that offer more than one pathway for the electrons to flow through. Okay, now that is one definition or one difference. We said in a series circuit, the current flows in one direction or the electrons flow in one direction. But in parallel circuit, the circuits, there are different ways or different places that the current, it has got more than one choice in parallel circuit, but in series circuit, there is no choice. Okay. When constructing a parallel circuit, we say that the components are connected in what? Parallel. As you can see, the series circuit, The bulbs, they were joined, they were connected in line. But this one, they are connected so that they are in the form of a parallel. So let's just look at the diagram which shows how two bulbs, light bulbs are connected in parallel, as you can see. So again, we have got the battery, which is the cell, and then you have got the conductors joining the light bulb. And one end of the terminal is connected to the positive, and the other end is connected to the what? Negative. Now, so what happens? As more resistors are added in parallel, the total current strength increases. Okay. Now, it means is that the current is more or is high. The overall resistance of a circuit must therefore have decreased. So what it means is that if the higher the current in parallel circuit, it means the resistance is low. So it's like there is an inverse proportionality. When we talk of inverse proportionality, it means when two things are in inverse proportion, when one is increasing, the other one is decreasing. And so for example, if I have A and B, if A is increasing, then it means B is decreasing. Then if B is decreasing, it means A is what? Increasing. Now let's look at this statement. It's saying as more resistors are added in parallel, the total current strength increases. Why is the total current increasing? The total current is increasing because the resistance is what? Decreasing. So now if I am looking at my what? Current and resistance in parallel circuit, what is going to happen is that it means if my resistance is low or is less, then the current is high. So it means the materials are not offering much resistance to the flow of what? Or they are not opposing too much to the flow of the what? Current. So that's why when the current is high, then it means the resistance is what? Low. But on the contrary, if resistance is high, it means the current is going to be what? Low. Okay. The current in each light bulb was the same because all the bulbs glow with the same brightness. This tells us that the current of electrons must have split up and moved through each other of the branches. We can also connect cells in parallel. What happens if we increase the number of cells connected in parallel? Will the current get stronger or weaker? So what it means is that we can add more of the what? The dry cell there, and then see what is going to happen to the current. Okay? All right. Somebody is following. That's nice. I thought you guys are sleeping there. Thanks very much. You are following. Now let's continue. Okay, now let's look at some more characteristics. Adding cells in parallel have no effect on the current strength. So you see that the current strength stays the same if you add cells in parallel. We say that the current strength increases when bulbs were connected in parallel because they offer half its strength. So it's just like if I have let's say, a bulb which is 1.5, then I have another bulb which is 1.5. When they combine together, I'm going to get 3. But when I connect the bulbs in parallel, it's just like I'm connecting one because this one is giving half, this one is giving half. They offering half their capacity. All right. Now let's go on. What have we learned about parallel circuits? So we have just learned that there is more than one way for the current to flow. And then the current divides between the different branches so that each branch gets some of the current. For example, if the bulbs are identical, the current will divide equally between them. All right, let me go back and explain this point. Now we can see that the wires are joined together. Now what it means at a certain connection point on the right hand side and on the left hand side. Now what it means that if the current is flowing, immediately they get to this junction, the current will divide and one will go to the left and then one will go to the valve that is on the right. Now what it means is that if they are the same, it means the current is going to divide what? Equally. But supposing they are different, it means this one will they will divide accordingly. All right. Now let's just go back to what I was talking about. Okay. Now the current divides between the different branches so that each branch gets some of the current. For example, if the valves are equal, the current divides the current divided are also equal, or the current also divides equally between them. If you add more resistors in parallel, the total current supplied by the cell in the circuit increases. If you add more resistors in parallel, the total current supplied by the cell in the circuit increases. So, in simple terms, when you add resistors in parallel, when you connect them in parallel, the amount of resistance that they provide is less. Hence, then the current is going to increase. But if you connect resistors in series, what is going to happen is that the resistance is going to be high. And if the resistance is high, what is going to happen is that the current is going to be what? Low. Okay. Now let's move on. Why does current divide when offered an alternative pathway? All right, now this is a very interesting example. Imagine that you are sitting in a school hall. I'm going to use this situation of the word school hall, and then you will understand this point, that question, which is why does current divide when offered an alternative pathway? Okay, now imagine that you are sitting in a school hall during assembly. You are bored and waiting for it to end so that you can go out to break to chat to your friends. But meanwhile, there is only one exit from the hall. When you are dismissed, you can see how many people are going to rush or scramble to the exit. You see that everyone is going to pass through the same exit. Now, it takes a while because only one learner can leave at a time. But what about a situation whereby we have got two? Now imagine that there is a second door that is the same as the first door. Now you and your friends have a choice of which door to go through. Now the speed at which the learners exit the hall will increase, and some of you will exit through the first door while others will what? Exit through the second door. No one can go through both doors at the same time. Yes. This is similar to the way current behaves when it is in a what? A parallel circuit. As the electrons approach the branch in the circuit, some electrons will take the first path and others will what? Take the other path. Okay, the current is divided between the pathways. So in the following circuit, so let's look at this. This is parallel circuit. The current in A is equal to the current in A4. Remember, A1, A is referring to the what? The ammeter. So when we say A1, A2, A3, A4, it means we are measuring the current that is passing where A1 is. We are also measuring the current that is passing at point 4, at point 2, and at point 3. So we said in a series circuit, the current is the same, but in a parallel circuit, the current is not the same. So let's watch. Now, let's look at this. So A1 is equal to A4. So when you measure here and you measure there, the current is going to be the same. Now, and A1 is equals to A2 plus A3. Do you get that? So what it means is that the current in A2 and A3 will not be the same thing as A1. So for us to get A1, we are going to add A2 plus A3 because there is a junction. When it arrives there, it's split. So supposing here is what is 2. The ammeter reading at A1 is 2. Now, if A2 is a different resistor like 7, and then A3 is a different resistor like 3. Now, what is going to happen is that the more current will pass through the resistance that is less, and low current will pass through the resistance that is high. Okay, now if you want to know the total current, then you have to say A1 is equals to A2 plus A3, so that you are adding all the what the current that is passing through them. Now, what happens is that as they exit, then they will separate again. But if you check, A4 is equal to what? A2. So if you look at the pathway, if you just look at A1, forget about that one, where there is ammeter 3. Now just consider ammeter 1, ammeter 2 going the top, going to ammeter 4. So they are saying A4 is equals to what? A2. Because when you consider only that passage or pathway, you see that it's in what? Series. Okay, and remember in series circuit, they will be the same, the current will be the same thing. So that's why the current in A2 will be equal to the current in what? A4. But if you consider it as a whole, and then you have the top and the down, they are connected in series. So when the current is entering, it will enter according to the what? The size of the what? The resistance. So the less resistance, there will be more current, and the higher resistance, there will be what? Low current passing through. Okay, let's go to the next. All right. Now, so this is just a simple circuit. We looked at this yesterday. Is there a question? Yeah, there are advantages. Okay, I think I mentioned them. Okay, so let's go. We will. Okay. Now somebody just asks whether are there advantages. Yeah, I just want to check something here. Who is that? Okay. Yes, somebody said there are advantages and both uh, advantages and disadvantages in both series and parallel circuit. Yes, yeah. For example, and one advantage about parallel circuit is that if you connect your bulb in parallel connection, the life that you have, the lifespan of the bulb increases. But if you connect the bulb to the what? In series, the lifespan is shortened. Why? Because in series, there is high voltage that enters there. And when there is high voltage, you remember there is heating effect. And at the end of the day, the bulb will what? Will will burn out. But that is not the case. Yes, but one advantage also in terms of voltage is that in series circuit there is high voltage, but in parallel circuit there is, you can say, low voltage. Now also one advantage is that parallel connection is used in what? Household connection. Because if we were to connect a household using series circuit, what it means is that if you are in your room and you just at 6 o'clock in the night or 7 o'clock in the night and you want to sleep, if you switch off your light in your room, then it means the whole house is going to be what? Off. Yeah, so that's one disadvantage. But for parallel connection is good for what? For connections at home, but series connection is not good. All right. Now, another advantage is that all the bulbs are what? The same in parallel circuit. If they are on, all the bulbs, they are the same. But in series circuit, that is not the case. So what is happening is that if you have got two bulbs connected in series and two bulbs connected in parallel. Now, if I remove one of the bulbs in parallel, the other one is still going to be on. But if I remove one in the series circuit, the other bulb is going to be what? Off, because there is a gap there. Okay. Very quickly, yes, that's what you are saying. Yes. Yeah, you know what you are talking about. Yes. Now, let's let's quickly go to uh, the next slide. So these are the components of the circuit that we should always remember because you will be using them in grade 10, 11, and even 12. So let's go to the next slide. Okay. All right. There is an assessment here. So there are four in number. Let me see. Yes. So what we are going to do, you are going to answer the questions. So number one, it says, what is the function of an ammeter? Number two is saying, list the three types of circuits. Okay. And number three is say, look at the three circuit diagram and run the circuit from brightest to the what? Dimmest. Okay, so let's get started with number one. What is the function of the ammeter? So let's get yes, I'm with you. So we are looking at number one. What is the function of the ammeter? Because the other time some of you said you are typing slow or your system is slow. That's why I'm just giving you some time to type and then I will comment. Just keep your answers posted. Yes, Google it too. Hi, you have a question? Do you have a question? Ask. I'm not seeing your answers to number one. What is the function of the ammeter? The one with the symbol A, with a cycle with an A in it. Okay, yeah. Yeah, that's correct. Perfect. Okay, so let's go to number two. Let's go to number two. Number two is saying list the types of circuits that you know. The type of circuits that you know. So if you were listening, you will be able to get the answer here. Keep post. Okay, perfect. Daniel, you are correct. Yes, keep posted. Keep posting. That's correct for 2 months then. They say you are also correct. Let's get going. All right. Okay. Let's go to question three. Question three is saying, let's look at the diagrams. Let's look at these three diagrams. Run the circuit from the brightest to the dimmest. So which of them is going to be dim? Is it number one, number two, or number three? So you are going to arrange them from the brightest to the dimmest. Okay, guys, let's go to all of them. One is only one bulb, but with 1 watt resistor. Okay, yeah, that's perfect. That's perfect. That's perfect. So the one that is connected in what? The three resistors connected in what? In series, in parallel, will offer much, followed by this one with two, and then the other one with one resistor will be the last one. Perfect. They say to you, that's correct. Okay, keep it up. Okay, let's go to number four. Let's go to number four. Let's go to number four. Okay, number four. Number four is saying, study this diagram. We should study this diagram. Okay, so this diagram is similar to the one that I was using to explain. It says, what is the relationship between the ammeter readings on A and A4, A1 and A4? In other words, how do the current strengths compare at this point in the circuit? Explain your answer. Okay, number two is saying, what is the relationship between the ammeter readings on A1, A2, and A3? In other words, how do the current strengths compare at this point? Okay. Keep your answers flowing here. Yes, I'm waiting. Are you guys there? Are you guys there? Okay, I can see that I'm waiting for you guys. Okay. Let's keep pushing. All right, we have got some few minutes left. Two less than 3 minutes. Are you guys winning there? So, okay. All right. The question is, what is the relationship between ammeter readings on A1 and A4? Are they going to be the same? Are they going to be different? Yes. So that's what the question is asking Daniel. So you see A1 and A4. If you measure the reading at A1, where the ammeter, if you connect it at A1, and then you measure and connect it at A4 in parallel circuit, are the values going to be the same? That's what the okay. All right. Somebody is saying the same. So just keep note of your answer. We will check to make sure that whether you are fine. Okay, Nyati. Nyati, really, the question is saying you must consider if in a parallel circuit, if I connect my ammeter here and measure the current, and I also connect that side and measure, are the current going to be the same? That's what the question is asking. What is the relationship between the ammeters reading on A and A4? In other words, how do the current strengths compare at this point in the circuit? Explain your answer. Okay. All right, guys, let me roll up and then we will get the corrections. Okay. So this is what you have. It is used to measure the current flow in the circuit. That's correct. We have got parallel and series connection. Those of you who said that, you are right. Okay. And number three, the third circuit will have the brightest. So those of you who said 3, 2, 1, you were perfectly right. And then that's the explanation there. And then A4, A1, A1 and A2, A4 will be the same because the total current flow to the circuit at both parts. Okay. And B, the A3 is equals to A2 plus what? A3. So the current split between them. So some of you were giving your answer for question 4, and others, you were giving your answer for 4B to what? AB. All right. Okay, so we have come to the end of the lesson, and then I hope you enjoyed the lesson. See you Monday. I hope we will be doing Kahoot on Monday in the next week, Friday. All right. Keep well and see you. Awesome. Let's say the awesome to thanks very much.